Okay, let's have a look here. There was a mistake in this question when I first did it, so I'm just redoing it. Z equals that, Z conjugate equals that, shown in Argand diagram, the locus K of Z such that. Okay, so we have Z minus 1 plus 4i equals Z minus 5. Okay, so if we, let's see now, um, I can draw a line here. Okay, so 1 plus 4i will be here. There's a 1 plus 4i, and then 5 would be like there. This being the imaginary axis, like we could say there's I and there's 1. Um, so we want the distance from Z to that point to be equal to the distance from Z to 5. So, okay, 1 plus 4i and 5. So I think that would make it like this line here, because every point on this line would be the same distance to 1 plus 4i and 1 plus 5. Yeah, so that's fine. Now let's have a look at this transformation here. I'm going to clean it up a little bit. So that would be a half Z plus a half Z conjugate plus I Z over 2 minus I over 2 Z conjugate. So let's try and clean this up a little bit here. This would be a half X plus a half YI plus a half X minus a half YI plus a half IX minus a half Y, because the I times the I makes I squared, which is minus 1, minus a half IX plus a half Y. So let's see, what can I cancel here? A half YI minus a half YI, a half IX minus a half IX, a half Y minus a half Y. A half X plus a half X is just X. So the transformation is actually to take Z to just the real component of Z. So it's projection onto the horizontal axis here. So if I just put this line in here, that would be the image of K. So there's F of K there. Okay. Okay. So that's part A. Now we can have a look at part B. So in part B, they want us to factorize this. Find the two, and they suggest the following factorization. So x power 4 plus 1 is equal to x squared plus px plus 1 times x squared plus qx plus 1. So that would be x power 4 plus qx cubed plus x squared plus px cubed plus pqx squared plus px plus x squared plus qx plus 1. So that's x power 4 plus q plus p x cubed plus 1 pq, 2 plus pq, that was the mistake I made last time, x squared, then the x p plus q x, and then just the 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we know that q plus p for this equation to be equivalent to the x power 4 plus 1, we know that q plus p must equal 0, and 2 plus pq must equal 0, and p plus q must equal 0. Well, p plus q and q plus p equals 0. So it's a bit funny. That's the same equation. So I guess I have two equations, enough to work it out. I could say p equals minus 2 over q, and I can sub that in here to minus 2 over q plus q equals 0. Multiplying by q, I get minus 2 plus q squared equals 0. So q equals a root 2. Well, plus or minus root 2. And then that would mean p is 2 over root 2, which is root 2. So minus or plus root 2. So now that we've factorized it, x power 4 plus 1, we factorized it into x squared minus or plus root 2x plus 1, and then x squared plus or minus root 2x plus 1. But if we choose the minus here and the plus here, that's the same as choosing the plus here and the minus here. So it's actually a bit redundant to consider both possibilities. It's enough just to consider this. Now, we can solve this using the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac. It should be imaginary. So that would be root 2 over 2 plus or minus root 2 over 2i. And this one here, minus root 2 over 2 plus or minus root 2 over 2i. Okay. Now let me pause the video and check my video from last time I did this to see what answers are different. Okay, so actually I did make a couple of mistakes in this video. When I was rewriting this, I rewrote it as z minus minus 5 for some reason. I should have written it as z minus 5. So I drew this on the wrong side. So I think it's correct now. That's not a big mistake. Well, it's a mistake nonetheless. But the bigger mistake was here as one of my think it was Gary who pointed out that I wrote a 1 instead of a 2 here, which had consequences for the rest of the answer, obviously. And hopefully it's all correct now. Let's just double check. Show an Argand diagram the locus such that, okay, I think I've done that. The transformation, show on the Argand diagram FK, which is the horizontal axis. Okay, that's okay. Using real numbers, find the two quadratic factors of that, hence or otherwise write down the complex roots of that. And there's the hint. So I think it's okay now. I hope so.